Your car wreck?
Oh, really?
Those two problems, please. And then I can answer any questions that you guys might have in the homework, and then we'll do chain rule. This is kind of combining some of the stuff we've done. So I would start off on both of these. As soon as I see find the equation, I'm writing down my form here. Just going to fill in numbers. So what, they like dropped their kid off and then came out and turned left and weren't paying attention?
They were like, so I was like driving, you know, in the parking lot there's the roads, and then there's like the road that you take to like get out of the high school.
Yeah.
Yeah, I was like driving on that, and
Yeah.
she just like yelled right into me, and I was like, what?
I feel like that almost happens to me like twice a week. Like they don't pay attention. Yeah. Like, oh, I dropped my kid off now, I do whatever I want. Traffic doesn't apply. Wait, wasn't someone in here's mom? I'm like making fun of them. So the x value is 3. I mean, you can start with that. Like even on the AP test, if you know nothing else, if you just put, so this is like part A, the free responses on the AP test are with 9. This would be like a part A of that. Even if you just put that 3, you might get 1 out of the 9. You might get at least something. It's better than putting nothing. What's going to go here? No. So the original, so to find this number, I plug into the original equation, right? I want the y value. Y value is f of x times g of x. So f of 3 times g of 3. So that's going to be 4 times 2. So that'll be 8. You see where I'm getting it from? Then how do you find what goes in that, the blank in the front? That's slope, right? How do you find slope? Derivative. What rule do you need to take the derivative? Product rule. this is always like find the derivative and then plug in. So your derivative would be the second thing. Second thing times the derivative of the first thing plus the first thing times the derivative of the second thing. So you're going to end up with g times f prime negative 2. F times g prime would be negative 8. And if you add those up, you should get negative 10 there. And then if you wanted to, you could. So I don't care if you do it. AP test doesn't care if you do it on free response, but on multiple choice, they might like distribute. So you get negative 10x. This would be plus 30 plus 8, so plus 38. Is that okay for one? You have a little more time for two, or are we good? Second one, same idea. To find the y value, I plug into the original equation. So f of 3 divided by g of 3, so that'd be 4 divided by 2. So that's 2. And then to find the slope, I'm going to take the derivative and plug in, so that's going to be quotient rule. So that's going to be the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So that is negative 2 minus negative 8 over 2 squared. So 6 over 4. What do you guys got? Or if you want to reduce it, make it 3 over 2, whatever. So that's just kind of like product rule quotient. That's where we're getting like starting to combine kind of all the stuff we're doing, like the tangent line, normal line, horizontal tangents. That stuff all carries on throughout the whole, all the stuff we're doing for derivatives, and then the derivative part gets a little like that starts getting hard. We're still always kind of coming back to these ideas. Questions here at all? Were there any on the homework that I should go through? So get that out and let me know. Yeah, Naomi?
Number 9.
Can you read it to me?
Y equals x to the 4th plus 1 times negative 4 x to the 5th.
Like that?
Yeah.
Okay. So, second thing times the derivative of the first thing. So rewrite the second thing. The derivative of the first thing is 4x to the 3rd. Second, derivative of the first. And then the first times the derivative of the second, which would be negative 20 x to the 4th. And then I just got it. Wait, is this a quotient rule or? Oh, there was no. Okay. Did we do quotient rule yesterday?
Yeah.
But I put some products.
The second page was product rule, and the third page was the charts.
Gotcha. Okay. So then multiply this through. So this would be negative 16 x to the 8th because you're going to add those up. Distribute here. So negative 20 x to the 8th minus 20 x to the 4th. And then combine like terms. So negative 36 x to the 8th minus 20 x to the 4th. How's that?
Can that simplify to, when I
What
checked
did
my
they put?
answer, I was actually looking at the top line where they did the first like expand thing, but they did it differently than we do, so it confused me. That's
Gotcha.
what I got. The
Okay.
answer just confused me.
Okay. All right. Cool. Anything else? Anywhere? Anything else? Was that it? Okay. Let's get your notes out. Let's do chain rule. This is the formula or the math way to look at it. You do have to know that because you get those charts with these problems too. It's not really how I'll talk through it. I'll more say the thing I wrote at the bottom. Take the derivative of the big guy, leave the little guy alone, and then multiply by the derivative of the little guy. I am. Thank you. You go back and watch it.
But I have a feeling I will once these things start getting more complicated.
Gotcha. No, I mean, I appreciate that. And then when we simplify these, I'm going to tell you no negative exponents. I meant that to be blue. It kind of bothers me that's not blue, but not quite enough to go back and fix it. So I know that just looks like gobbledygook right now, but let me do a couple and then hopefully that'll make sense. How about you guys have this copy? Are we good?
Not yet, no. Translation.
Good? Alright. So, chain rule is nice because it saves us a lot of time. So as a simple example here, let's say I gave you 4x to the 5th, or 4x plus 5 to the 6th. That's 6. If there were not chain rule, you'd have to do 4x plus 5 times 4x plus 5. Foil it. Take that, multiply by 4x plus 5. You have to keep doing that, and that would take like the entire hour just to do that. And then take the derivative of everything, and then combine everything, and it would suck. Chain rule allows us to look at it and say, okay, there's really two things going on here. There's an outside kind of dominant function, and there's an inside function, or what I'll call like the big guy and the little guy. So the outside function here is the 6th power. That's like your big guy or your f of x, if you want to think about the f and the g. So this is chain rule. Same thing I already wrote down, I'm just putting it on this slide. So the f is taking this g of x to the 6th power. So g of x is the 4x plus 5. Can you see that? So g of x is the 4x plus 5. And then the f says take whatever that was and do it to the 6th power. So this is like your big outside function. That's your f. This is your little function, or your inside function, or your g. So to take the derivative, this is our f. So the first thing we do is take the derivative of f. So the derivative of f, well, f is a power. F is the 6th power. How do I take the derivative of the 6th power? Well, that's power rule. I bring down the 6, and I reduce the power by 1. That part right there is my f prime. I took the derivative of the 6th power. So power rule says you bring it down, you put it in front, you reduce the power by 1. So that's my f prime. What happens to g of x? It stays the exact same. So that's what I mean by leave the little guy alone. So g of x stays g of x, and it still goes there. So that was g of x, this is still g of x. Now you multiply by the derivative of the g. So it's like we do the big guy first, we leave the little guy like it is, then we kind of move on. Okay, now let's take the derivative of the little guy. So what's the derivative of 4x plus 5? 4. And that's a perfectly valid answer. The AP test on a multiple choice would probably rewrite it. And just multiply the 4 and the 6. And then I can say, what's the slope at 2? What's the derivative at 7? Find a horizontal tangent. It's like I can still do, what's the tangent line here? I mean, I can still do all that stuff. Just we're making the derivative part a little more advanced. Yeah. Okay. questions on this one? Okay, let's try it. Let's say y equals the square root of 3x squared plus 4. So now I can put roots in, I can put negative x, like I can do a whole bunch of different stuff now I couldn't do 10 minutes ago. So the first thing I would do is rewrite this as 3x squared plus 4 to what power? Square root is what power? 1/2. So what's your outside dominant function, like the big guy? The 1/2 power, and what's your inside, your little guy? 3x squared plus 4. So my first job is take the derivative of the big guy. So the derivative of, that's a power. So to take the derivative of power, I use the power rule, which means bring it down in front, reduce the power by 1. We leave the little guy alone, so the 3x squared plus 4 stays in there. And then we multiply by the derivative of the little guy, so times 6x. And that's the chain rule part. I still have to simplify though. I told you no negative exponents. So now we get into, okay, we got to have a top and a bottom here. We got to get rid of the negatives. So this 1/2, that kind of splits the fraction for us. 1 on top, 2 on the bottom, and then we're going to identify everything else. Does it go to the top or go to the bottom? This is a negative exponent, so to make the exponent positive, where do I have to put it? On the bottom. So now it's to the 1/2, and then the 6x goes on top. And you're totally welcome to leave your answer like that. That's a legitimate answer. The AP test would probably say, okay, there's just a 3x on top. And just like reduce the 6x over 2. Questions there? Yeah?
What they do when they retest it and put it back in the square root of the
No, they would. I guess they could. I don't think so. Actually, now that you say that, they probably do that sometimes. But that's not that bad either, right? I mean, you can identify that. So they could write it as like 3x over the square root of, like that. Alright, let's keep going. That's kind of it. I mean, there's not that much beyond what I just showed you at this point. Let's say, that. I put that 2 in like later, so if you were copying before I put that there, make sure you catch the 2. So today it starts off simpler than it can get, because every single time, I think on every problem we do, the big guy is going to be the power. It's always like a little guy raised to a power. But as we move on, the big guy could be cosine, tangent, cosecant, e, natural log. Like we got all this other crap that can kind of get in the mix and make things tougher. So for right now, again, we're laying the groundwork and we'll get harder as we go. So this is your F, or your big guy. This is your G, or your little guy. They used to say this is Mr. Zupi and this is Mr. Packard. Mr. Zupi lost a bunch of weight though, so can't say that. So my job is to take the derivative of the big guy first. Big guy's a power. How do I take the derivative of power? Bring it down in front, reduce by 1. So that it comes down in front and multiplies by the 2 that's there. So negative 6, reduce the power by 1. What is it now? Negative 4. Naomi, yeah.
Why isn't the 2 part of the big guy?
A constant isn't a big guy or a little guy. It's just kind of there. It's just, no, it's not even that. It's just like an observer almost. So like x squared, 2x squared. Do you take the derivative of those any differently because that 2 is there? I mean, you still bring down and multiply, right? So technically, I could say this: there's always been a constant there. It was just a 1.
Okay.
So it doesn't really affect things. It's just kind of like it's just hanging out. What do I do with Mr. Packard? Leave him alone. Don't bully Mr. Packard. That's not nice. And then what I would then multiply by what? Derivative of Mr. Packard, which would be 8x minus 3. Did I write that correctly? I did not, but that's a very common mistake. So what I just wrote was negative 6 times this to the negative 4th times 8x minus 3. What I want to write is times all of that. So you have to put parentheses around what you're multiplying by. The first two I didn't have to do that because there weren't like two terms to the derivative. If there are more than one, it might just be a good idea to always put in parentheses, but now I got to make sure I put that there. Now I cannot have negative exponents in my answer. So if there were a fraction here, like if there were 2/3, that would just split it for me. It would tell me top bottom. There's not a fraction. So I can just go like negative 6 over, I can write the 1 there, but there's no real reason to. But that fraction here is really negative 6 over 1. Where is this going to go? On the bottom, because I need to make the exponent positive. 8x minus 3 goes on top because it has a positive exponent, and then that'll be your answer. But if you want to multiply on the bottom here, or the top, you can, but you don't have to. Questions there? Do this one. Go.
Yeah, that was so interesting.
You did. Should probably make sure we're starting from the right spot here. What's the power? What power is that? 1/3, right? Because it's like the stuff in here is to the first, and you always do the inside over the outside. So again, this is your outside, your F, or your big, whatever you want to think about it as. This is your little, or your inside, or your G. So your job is to do F prime first. So F prime is bring down the 1/3, reduce the power by 1, leave G as it is, and then multiply by G prime. Again, what am I forgetting? Gotta have parentheses there. Well, that's my answer. It's not simplified yet, but that's my answer. Now get rid of the negative exponents. So the 1 and the 3, that chops it up for me. The 4x squared minus 2x goes on the bottom. The power will become positive. And then the 8x minus 2 goes on top. Either erase that 1 or like put that in parentheses so it doesn't look like 18 or something. So I'll probably just do that. Questions there? How many had that? Awesome. All right. We got to go through how to do the chart thing, but before we do that, I want to make sure. I almost have to back up to like advanced algebra for a minute. Let's say f of x was 2x squared, and g of x was x plus 5. And I ask you to find f of g of 3. that could be written either like this or like this. So these are saying the same thing. Equal. Do you know how to do that? Do you remember how to do that? So try it. Let's see. Bigger number than I wanted to. No derivative. We're just, you don't even know calculus at this point. This is, you're making like advanced algebra. Just find out the G of 3. I'm getting to the calculus part in a second, but I want to make sure we're okay here before I went ahead. So you take 3, you plug it into G, what do you get? 3 plus 5 is 8, and then you take the 8, you plug it into the F. So 8 squared is 64 times 2, and that'd be 128. How many at 128? Is that okay? Are we good there? Okay, let me pull, these are hard to like make up, so I'm just going to use the ones on the cheat, use the computer program. So let's look at a couple of the chain rule with the chart. So let's look at these. Do you want a second to write down the table? Alright, give me a second to write down the table. And the questions, I suppose. She just left. She'll be there in like 10 seconds. Hey, what's up? Alright. I get like 3 calls a day for the rock tables. Good to go? Are people still ready? Okay. So, 2 different ways to kind of present the chain rule here. In this first one, in number 1 that I wrote down here, what's the big guy? The 2, the power, and the little guy is the f of x. So if I were going to take the derivative, I do the power, reduce it by 1, leave the little guy alone, and then multiply by the derivative of the little guy, so times f prime of x. and they're asking me to plug in 2. So h prime of 2 is going to equal 2 times f of 2 to the first times f prime of 2. So you don't really need the composite stuff for this one. It's the second one we need the composite thing for. Here we're almost just kind of multiplying. So 2 times, well, what's f of 2? F of 2 is 1 to the first power, so I don't really need to worry about that. And then f prime of 2, well, that's 0, so that makes the whole answer 0. I mean, the answer's not really my concern here. Do you see what I'm doing? Where are we getting stuff from? What's going on? Second one is a little bit trickier. Not too bad. Can I erase this? Am I still right? So for the second one, that you actually have to know like the rule, the technical way it's written out. So, I mean, you could think about it, think through it though. So in this one, f of g of x, what's your big guy? F, right? That's like the one on the outside. So take the derivative of, so here, if h of x equals f of g of x. And I want the derivative. You take the derivative of the big guy or the outside function. What do you do with the little guy? Leave it alone. And then you multiply by the derivative of the little guy, or of the inside. That's chain rule. That's like the technical definition of chain rule right there. And then they want me to plug in, and this one I'm plugging in 3. And this is where we need the composite stuff. So what's g of 3? 4, right? G of 3 is 4. So then they're saying, okay, find f prime of 4. Like you're plugging into 1 and then the next one. See what I'm doing? So what's f prime of 4? F prime of 4 is 1, isn't it? Times, and then the g prime of 3. Then I can just read off the chart. So g prime of 3 is freaking 0. So it's 0 at the end anyways, but I don't care about the answer. Does what I'm doing make sense to you? Questions on it? Try that one. Better not be 0. Jack, you go back to the table. When they're back in. Turn around and shift left so sky and then table. Anyway, Jasper. Guys get -8 for the first one? Well, I just ruined it for you. I'm sorry. Spoiler alert. Oh, I'll do a second. tomorrow we can start doing. We can combine the rules. So now you get a problem that has like product and chain in it, or quotient and chain, or product and quotient, or mixing everything up. Mostly it's product and chain. And it just becomes like a ton of algebra. Was the first one okay? Somebody had -8 for the first one. Okay. Questions on number one? Second one. So your derivative would be, take the derivative of the outside, leave the inside alone, and then multiply by the derivative of the inside. So then h prime of 3 is what they're asking for. So g of 3 is 4, and then I want f prime of 4. So this is 2 times g prime of, you gotta be kidding me. So it's 0. How many had 0? Questions on what I'm doing though? Does that make sense? I think yes, that's okay. That's your homework. Got that done for tomorrow. We'll have questions and move on. Do you have a question?
Yeah, I'm just not having to gut to.
I got the 2.